I'm here with Aryeh Batt from Precise Bio. Aryeh, at this meeting, I learned a lot of new things. But you're from the 23rd century. It's almost science fiction. What you guys are doing. So you're producing tissue that can be used clinically. Can you spell this out? I have a million questions, but tell me just grossly what it is that we're talking about.
What we are doing at Precise Bio is in the field of regenerative medicine, specifically tissue engineering. And what we are doing is reducing to practice, I would say, 2 decades of science that has been matured in various fields. It's cell technology, biomaterials, and what we are doing is commercializing these technologies, specifically focusing now in the field of ophthalmology, where there is a great advantage. The ophthalmology field is an innovative, related field that can adopt new technologies. And as you said, it seems sometimes science fiction, but we are reducing it to practice, and now are at the preclinical stage in our first indications.
So if we spoke a little bit off camera, and maybe I have this wrong. You're printing tissue. Actually, let me tell you a little anecdote. Okay, my visual field machine has been a workhorse. It's great. The little lens holder broke. I have a 3D printer, which that my love for it rivals only my love for my family. Okay, and I was able to print a new lens holder. I was very proud of that. You're so far beyond this. So you're printing tissue.
So we at Precise have developed a unique proprietary 3D printing technology where we can print at very high resolution, I would say single cell resolution, where we could deposit cell by cell human cells and keep them alive, and these cells will structure the tissue in the same anatomical structure as it is in the body. And think it, as you have a 3D printer, you do layer by layer, you have a 3D image where the computer reduces it down to two-dimensional layers, and then you build it layer by layer. And we are doing exactly the same thing, but with human tissue and human materials. Doing layer by layer, printing a layer of cells, on that another layer of cells, other biomaterials, and this way we can structure the tissue exactly as it is in the human body.
Now, let's talk about a use case, which is producing tissue for DSEC. What are you doing, and what is the tissue that the clinician will eventually be able to get?
So that's very interesting, because we want the clinician to have a tissue that he is familiar with. So we are structuring the tissue exactly in the same structure as he is familiar today. He's going to be using the same tools that he's been using today to transplant the tissue. But this tissue is coming not from a donor, but from a 3D printer that will extract this tissue when you do Control P, as you do in your own printer, and you will get a human tissue ready for transplant by the clinician.
Absolutely wild. Now, obviously, you are not de novo creating endothelial cells. Those are coming from donors, but it's not a one-to-one process, right? It's not that one donor produces one of these corneas. How many corneas? And I understand that this is preclinical, but how many printed corneas can you get from a single donor?
So part of our technology, and essentially when we look at a human tissue, it's comprised from cells. So what we do today is we take a human donor cornea, we extract the cells, we expand them today 70, 80-fold. So from one donor, we are able to fabricate today 70 donors, and this is a number that, if we look worldwide, is essentially what is missing today in the field.
Now, if this were all that you guys were capable of doing, it would still be science fiction, or it would still be unbelievable stuff. But I understand that what you've done is you've produced a sort of a generalizable platform that can be used for different applications. you talk a little bit about that?
So when we talk about our platform, and our platform technology is not just the printer. Our platform technology is the cell biology, the biomaterials, the method how to fabricate a tissue. It's how you mature a tissue, how you mature the cells after you print them. And these technologies can be moved from one indication to another indication. We started out with the DSEC. We have moved to the ocular surface, which are now also in a preclinical study. And we can imagine it going into many, many more indications because the platform is there, the basic technologies are there. We tweak the materials, we tweak the cell technology, and we can move from indication to indication and really address many ophthalmology needs down the road.
And presumably not just ophthalmology, but lesser organs also.
Well, that's correct. The company Precise is focusing now on ophthalmology, but we have also an R&D project in the field of cardiology. It's early stage, at the basic stage, but we have printed cardiac tissue. We have printed liver cells and other types of tissue down with our platform technology. Focusing now on ophthalmology, this is the first area. It's a market that can adopt innovation. We are reducing it to practice and bringing it to the clinicians so they'll be able to bring it to the patients.
Aryeh, just one last question. Where are you on the road to commercialization? When am I going to be able to start to use this product?
So we are in the preclinical stage now, currently doing studies in rabbits. We anticipate that in 2021 we will start our clinical phase, and running through the clinical phase also together with our regulatory path, working on that at this stage to define the regulatory path together with the regulation. And we see that at 2021 our clinical stage will be on the road.
Unbelievable stuff. Aryeh, I want to thank you so much for bringing this really, really cool topic to us, and for being so very generous with your time with us today.
I thank you for giving us the opportunity to bring this to people to see, because we are very excited about it, and we think at the end of the day the patients will be benefiting from these technologies.